Hi everyone, good morning, good afternoon, good evening, wherever you are. We are back again with our sneak live stream. And this live stream is all about stranger dangers. So we're going to be talking about a lot of dangers which we know, which we don't know. So open source software has become increasingly popular. We all use it day in and day out. We accept it or not, but most of the internet is all open source. Some of the code is written by us. However, open source software also pose certain risks or challenges that we're going to be talking about in Stranger Danger session. So we would be exploring lack of patches and updates, vulnerability dependencies, security awareness among developers, transparency in the development process, licenses and whatnot. Now, let me bring my friend Sonia Moist, who's going to be talking about stranger dangers in JavaScript. So let me just get her in. Hi, Sonia.
Hey, hi everyone. Hi, thanks Vandana. Thanks for having me and Patch for today's session. Let's learn a little bit more about vulnerabilities and how to fix them and make the world a little bit more secure. Let's do this.
Absolutely. Let me go ahead and get your screen in. Here you go. The stage is all yours. All the
Cool.
best.
Thanks. So welcome everyone. Welcome to the Stranger Danger. Your JavaScript attack surface just got bigger. So what are we going to see and talk about today? So first of all, we are going to talk about the current state of OSS and what are the hot topics about open source software. We're also going to have a look at the iceberg, and you might be like this little emoji saying, "What is she talking about?" But I'll explain it to you. Then we're going to have a live hacking session with Patch. Patch is going to help us remediate the vulnerabilities, and we're going to have some learnings along the way. So first of all, let's start with the current state of open source security. So we know that organizations of all sizes are reliant on software, and that this software consists of a lot of open source software components. And thus, the OSS has cybersecurity implications because it's actually an attractive entry point for people and organizations that are interested in theft, disruption, or exploiting economic or political gain. Thus, we think that the attack surface is changing, and we're going to talk about this in a little bit. So we've seen it also 2 years ago now that defects in small libraries can cause systemic risk with the example of Log4Shell. And we've seen some incidents with that. So vulnerabilities can originate from something as simple as a configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for businesses. So one recent study revealed that out of 85,000 applications that were analyzed, 83% contained at least one security flaw. And of these, 20% was a severe vulnerability. While not all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate softwares. And we have organizations such as OWASP, which stands for Open Web Application Security Project, that tracks vulnerabilities found and provide a list that developers and security teams can use as a starting point for their application security program. The most recent one is the Always Top 10 list that were released in 2021 and included vulnerabilities like broken access control, injection attacks, security misconfigurations, and others. So let's have a look at some of the open source software attacks. The first one is typo squatting attacks. So typo squatting attacks takes place when bad actors push malicious packages to your registry with the hope of tricking users into installing them. This is quite similar to website phishing attacks that exploit typos made by individuals who may accidentally typing a wrong address. Here we have an example with the package React with a typo. And in that case, you will not install React, but a malicious package that has a completely different end goal. Another example is malicious packages, which injects malicious code into a software product in order to compromise the Panda chain. So in this example, we're having a package called Fall Guys, and usually the malicious actor will try to surf on trends. And in that case, again, that game has been popular during the pandemic. So users might think that by downloading this specific package, they will get an advantage in the game. Should it be cosmetics or having just a way to cheat within the game. So here in that case, Fall Guys is a malicious package that contains malicious code that attempts to read local sensitive files and exfiltrate information through a Discord webhook. So this was the entry point, the Discord webhook in that case. And basically, it was attempting to access specific paths available on Windows systems, and it was checking the local storage. One last example is compromising maintainers, where malicious actors will use social engineering methods to gain access to open source projects. Here we have an instance with the event stream package where the malicious actor did social engineer the maintainer. And that one is interesting. So basically, the process was to go through all of the issues on the repo and have a look where he could potentially add some code and contribute to it. So at first, he pushed some cosmetic changes to build up the trust with the maintainer. And once he got more permissions, he pushed his malicious payload into the code base. In that case, it was targeting a Bitcoin wallet. So his modus operandi was quite interesting. And going through all of the issues, see if he can contribute, be trusted, and then push his code. So this is known as a supply chain attack, also called third-party attack. And it usually occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. So the bad news is it doesn't affect only JavaScript packages. This is an issue for all ecosystems. And remember, 2 years ago, we had an example with Log4Shell within the Java community with the vulnerability in the open source Apache Log4 logging library, where one of the Log4j exploits allowed remote code execution on the servers, running vulnerable applications without requiring authentication. And that has earned the vulnerability severity rating of 10 on the CVSS scales, which stands for Common Vulnerability Scoring System. So Log4j was used in many commercial applications and still used in many commercial applications. And organization might be vulnerable without knowing that they are actually using the logging library. So supply chain attacks are quite attractive to hackers because when commonly used software packages are compromised, then it allowed them to potentially gain access to all of the enterprise that use that software. So let's try to understand how this is possible. And let's say hi to the iceberg. Hi, the iceberg. So if you're confused by that statement, let me explain it to you. So that's the iceberg. Let's look at the tip of the iceberg. So this is our starting point, which is our code. That's the proprietary code that we write in an organization. Does it bring security vulnerabilities into our code base? Maybe, maybe not. Let's see with that specific example. So here we have a function signature of an Express application with a function that has a request, a response, and an X callback. So it's doing a call to the user table or collection, which means that on the backend, behind the scene, there's a database. And it's trying to do a logging, looking for the username and password. So what can go wrong here? What are the vulnerabilities here? Here we have a perfect example of a database injection. And in that case, more specifically, a NoSQL injection. So usually applications built with Express will have body parser to parse the JSON objects, and it takes whatever you send to and convert it to a JavaScript object. So if the request has a username and a password, this is going to be part of the JavaScript object. If you're using MongoDB and add the $ greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do a greater than match to filter all the results. So you can send a request with admin as the username and this object to perform a NoSQL injection in this piece of code. And you'll be logged in as the admin. So this shows the importance of sanitizing inputs and to handle this as soon as possible before it's stored into your database. So we start with our code where potentially we can have security vulnerabilities. And also, this is another example of a piece of code where we're importing a dependency, which is actually a nice segue to the layer below the application code on the iceberg, which is the open source code. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we don't want to reinvent the wheel, and this is totally understandable. Why would we want to waste some time to write something that might probably exist as a package in our ecosystem? So that's what we have here with the Mark package. So the Mark package is essentially allowing you to use Markdown within your projects. But now we're bringing several packages into our code base. You can see all of these little npm packages icons on this graph. So increasing the attack surface and introducing new risks. So we have a few questions actually that we need to keep in mind. Are we aware of all the packages that we have? Are we aware of all the dependencies and sub-dependencies that we have in the project? Also, do we have a good understanding of the indirect and transitive dependencies? Do we have tools that help us having that level of understanding and visibility? But also, what are the risks when we bring a dependency into our code base? So I know that's a lot of questions, but let's see some numbers around that. So some of the cybersecurity challenges in OSS, we can see that the average number of outstanding critical vulnerabilities in an application is around 5, and this will depend on the programming language that you're using. Also, the average dependencies per project is around 80. Again, this will depend on your programming language. But the one that's most scary is the last number, which is the average number of days it takes to fix a vulnerability, which is around 100 days. So enough chatting for now. Let's move on to hacking an application and understand more about how dependencies can impact your application and introduce vulnerabilities that you were not aware of. So let's move on to our organization, Sneak Labs on GitHub. This is where I'm gonna use the application that I'm gonna try to hack. So basically, yeah, you could just git clone some of the app, the one with the keyword goof that will that you can actually download and just have a play with them. So the first one is a patch to-do list, really fancy application as you could see. So I'll just put my attacker's hat and think how I could tamper with this application. There's a few entry points that are interesting. Let's have a look at the URL here. So obviously, because I've git cloned the repo, I've installed it, I've set it up on my machine. This is why you can see the local host. But imagine that you have that application hosted on a server. So let's try to tamper with this URL. So the idea here is, as an attacker, I would like to reveal some sensitive info. I'd like to learn a bit more about the application, potentially the architecture, try to find some sensitive info, I don't know, like some credentials or passwords. This could actually help me to further attack the application. So let's have a look here. Just going to put public, for example. Oh, interesting. Okay. So here I can have access to a few folders. And you might think this is not quite interesting. Like you have access to CSS, to images, JavaScript, robots. Okay. Yeah. Let's see if I can go up more. Oh, okay. That's interesting. So what I was trying to do is actually performing a path traversal. So I'm trying to traverse the directories to try to find sensitive info. And basically, by using the // command, I wanted to check the parent directory of the current directory I'm in. And in that case, it goes back to the front page, which is a good news because it means that there's some sort of sensitization going on in the back end. But I'm a smart hacker, so I'm going to try to bypass this sensitization. So I know that I want to use this command, the // but apparently I cannot perform it here. So what I'm going to do is actually URL encode this // So if you're not familiar with what is HTML URL encoding, so basically what I'm going to do is replace unsafe ASCII characters with a % followed by 2 hexadecimal digits. So what I want to replace is the dot dot slash in that case. So this will be the dot here with the %2e and the slash with the %2f. Okay, let's try this and see if it works. So I'm going to go back to the public folder and do this. Okay. So I did bypass the sanitization in that case using the URL encoding. Cool. So now as an attacker, I have access to a little bit more information here around the application architecture, and I can understand more about the routes, about the what they're actually using for this application. But what I'm more interested in is credentials, passwords. So let's have a look. Deploy Heroku. That's interesting because you have a little bit more background and context on how they deploy the application. Docker Compose YAML. Okay. Oh, yay, bingo. Here, MySQL database password. Okay. That's a good start. Dockerfile. Okay. What I'm going to do is actually try to continue going up in this folder. So let's see what I can have access to. So here, because I mentioned that I've actually installed it locally, obviously you will see the folder that I have on my device. But imagine you're hosting it on a server. You would potentially have access to your server folders and files. And here you can see that I have access to the Etsy folder, which is not great news. Obviously, I'm not going to click on this and reveal sensitive info, but you get the gist of it. So what is going on here? Because we started with a to-do application, and now I have access to credentials and the Etsy folder. So let's have a look at the code. So going to my IDE, I'm using a Visual Studio Codes here. I know that for serving static file, I'm using the ST package. So that's the one that I'm using here. I'm recording it here, and I'm instantiating it here. Cool. So I want to know if this package is actually secure because I can perform this path traversal vulnerability. So let's have a look. And I'm going to ask patch help in that case. And what I'm going to do is go to the marketplace, and you can just type in Snyk. And you can install the Snyk security ID integration here. So you can install it. The first time you will have to reload your ID just to take into account. And you will have this little patch icon here on the left sidebar. And if you click on it, you won't see this at first. You will see a patch icon here asking you to authenticate. So if you have a Snyk account, you can just authenticate, and then you can start triggering scans. So here, bad news, Snyk found 93 vulnerabilities in our project. Cool. So let's have a look. Here, there's a few vulnerabilities here around ST, the ST package. So we can see there's like 2 vulnerabilities here. What I can do also is, as you can see also, if I hover here is like 2 vulnerabilities, but also I can go on the package JSON, hover here, click on the little yellow light bulb, show the most severe vulnerability, and here, interesting. Just gonna remove this, have a little bit more room. Cool. So directory traversal, interesting. That's the one that I've been performing, the attack that I've just demoed. Cool. So at the top, you have a little bit more info on directory traversal, all the CVs, info around that. You also have a link with learn about this vulnerability. So if you click on this, you'll be redirected to the Snyk Learn platform, which is a free platform where you can learn more about all of these vulnerabilities. And we do have one on directory traversal, which is cool. So you can have a look at it's like a 1-pager hands-on labs where you have a little bit more context around the vulnerability, and you can actually try the payload. Everything is sandbox, so it's safe to do it on your browser. The good thing is it's actually taking in account your progress, because you can create an account on it, and yeah, just learn a bit more about all of these vulnerabilities. Cool. Going back to the ST package, we can see that it has been introduced in this version, that actually the version that I have for this application. The good news is it's fixed in this specific version, and there's a proof of concept. So let's have a look what is going on. So the version prior to this one didn't properly prevent path traversal. Yeah, we've seen that. So the literal dots in the path were resolved out, but the real encoded dots were not. Thus, a request like the one that I've actually been performing would leak sensitive files and data from the server. Okay, and it's also giving you a little bit more context around what is a directory traversal attack, or also path traversal. And so it's defined as aiming to access files and directories that are stored outside of the intended folder by manipulating files with the // sequence and its variation. And we've been using the variation of this sequence with the URL encoding. And this leads to information disclosure. As we've seen, we did find some database credentials. And the ST module for serving static files is known to have that vulnerability. Cool. So now that we have all of this context in mind, we want to fix this vulnerability, obviously, because I don't want it in my to-do lists. So let's go back to the package.json and let's fix this. So looking at the ST package, I'm just going to bump the version. Ooh, minimize this. Gonna stop the server and do an npm install to install the new version of the package. And then we'll restart the server. So here we can see that I've created the to-do list. And I didn't want to create the piece of code to serve the static file. I've actually implemented a package to bring that functionality. But unfortunately, I did bring a vulnerability within my code base. The good news is I should have fixed it now by now. So going back to this application, if I refresh the page, yeah, this is now gone. This has been fixed. Cool. So let's have a look at, just going to zoom in. Patch here. So here, if I scroll down to ST, you can see there's like two vulnerabilities, the directory traversals. So let's trigger another scan, and this vulnerability should be gone by now. So it usually takes like a few seconds to scan your project. It's coming back with the results, and yeah, we only have one here, the up and redive. Cool. Okay, we did fix one vulnerability. Let's go back to the front page, and let's try to find other ways that potentially we could tamper with this application. So the main one is right in the middle, this input box. This is quite tempting. Usually the first thing that we would do is to have this script tag, and oh, it's not working. Okay, so good news for the application. There's some sort of sanitization. Okay, that's cool. Now let's try different things. So at first, let's see what I can do with this tool list. So okay, I can do just normal to-do items. Let's try with Markdown. So yeah, so Markdown is working here because we've actually implemented this feature by implementing a package, which is the mark package that I was mentioning earlier. So what is cool with this is actually you can use the Markdown language here now to partify your text, but also to use some features like links. So if I do right click here, I'm redirected to the Snake website. So this is working. Okay. That's an interesting piece of information because now I can try to craft a payload using this Markdown feature within that to-do list. So let's try with this. So I'm basically using the same format to do the link here, and I'm using the JavaScript colon protocol. So let's see if this is working. Okay, that's an interesting response that we're getting here. Okay, just a closing parenthesis. So I'm checking if there's any like specific sanitization in place, and in our case, it seems to do some filtering if we have the value of JavaScript colon, which is potentially could be a vector of attacks. Cool. So let's try to bypass this, and let's try to URL encode what we just type in. So here, what I'm doing, I'm using URL encoding. So let me just show you what is URL encoding. So what we're going to do is encode the colon. So let me find the colon. So it's here, colon. We're going to encode it with this. And we're going to encode the closing parenthesis, which is here. Cool. So if I go back to here, just going to zoom. So this is the colon, and this is the closing parenthesis. Oop, this one. Cool. Let's see if this is working. That's an interesting response. We have nothing here. But for a hacker, this is actually a kind of response. This is usually the kind of feedback that potentially malicious attacker can think as improving the payload and crafting a better payload, just to build up on all of this response. Because we started with a link, then we had the closing parenthesis, then we had nothing. So maybe something is going on the back end. So let's try a different variation with this. So here we're having still the same format with the link using Markdown. We're encoding the colon, we're encoding the closing parenthesis, but we're using the this keyword here. So we're still using the JavaScript colon to try to break out of the logic implemented in the backend that is blocking us from hacking the application. We are assuming that the condition must expect exactly the JavaScript colon protocol, but in this case, we're encoding it, and we're adding the this keyword, which is a valid keyword in JavaScript. And you can replace it with window or document. It will also work in that case. So we have the HTML entities and the browser's permissiveness that will enable this vulnerability. And here we go. If I click here, it's working. So let's try. We could potentially try with other things. Yeah, so in this application, we don't have cookies, but you could imagine if you have the document.cookies, it will actually reveal your cookies in that way. So what can we conclude from this? So as an attacker, it gives a way to perform an attack and break out of the logic that is preventing the JavaScript to be executed. And for an attacker, that's the first step when testing an application, to see if there's any entry point to craft a better payload. So this is a perfect example of a stored XSS, because if I refresh the page, all the payloads, malicious payloads, are here. So like this one. And the payload is also saved in the database. So if we think of a social media application where we have user profiles, because you might say, okay, Sonia, this is great, but I'm clicking patch alerts. I only have an alert. Is this really dangerous? I would say let's think differently. Let's think of this application like as a social media application. For example, if you have that example, and where you might have user profiles. So visitors could click on the link on your profile, and the data would be sent to the attacker server containing sensitive information. In that case, if you have the document.cookies, for example, or just to fetch your session cookies. Cool. Let's go back to the code and let's try to understand what is going on. So we know that to use Markdown within this application, we've been using the marked package here. And we can see there's a lot of vulnerabilities within this package with the specific version that we're using. So let's have a look where we are installating it. Here. Cool. So we can see that we've actually did a little bit of due diligence. We've set up the options. We set up the flag to truth for sanitize. So I did a little bit of research and tried to make it a little bit more safer, but we've actually failed because we managed to bypass that sanitization. So let's go back to the package.json and let's hover over this marked package. Click on the yellow light bulb, show the most severe vulnerability. And here you can see the XSS, cross-site scripting. This is exactly what we're having, and which I demoed here. So again, you have information around the CV, the CVSS marks, and you also have a link to the SnakeLearn platform to learn more about this vulnerability. So if I go back to SnakeLearn here, I have to type XSS. You can also, this one is for Java, but yeah, if you go back to lessons, here you can filter by ecosystem, and here is the one on JavaScript. And yeah, same, you'll have a one pager with hands-on labs to just have a try and better understand what is cross-site scripting. Cool, so this one has been introduced to the version that we're using, so this one. And the good news is there's a fix in this specific version. Cool. So let's have a look at what happened in that case. So there's a little bit of definition around marked, which is a low-level compiler for parsing Markdown without caching or blocking for long periods of time. Also, it allows us to use Markdown within our project. But the most interesting bit is here. So the affected versions of this package are vulnerable to XSS. An attacker could bypass its output sanitization, the one that I've just showed you, protection, by using encoded URL, encoded HTML. And that's the one that I've showed you just earlier on it. Cool. And by doing this, I'm performing a cross-site scripting attack. This occurs usually when the attacker tricks a legitimate web-based application or a site to accept a request as originating from a trusted source. And in our case, it was a stored XSS. Cool. So now that we have a little bit more understanding of what is going on with this package, we want to fix this because I don't want to have XSS in my application. So let's go back to the package.json and let's change the version of this package, which is this one. Cool. Just going to on the server and do another npm install. If I can see it. Cool. So again, you can see here, I tried to serve the static file and try to implement Markdown within my application because I didn't want to reinvent the wheel. I knew that packages existed for that specific cases. The bad news is I actually brought some vulnerabilities within my application. And the good news is if you know, if you have a better context about that and that understanding, you can actually update your packages to a safer version. Cool. So going back here, I'm going to refresh the application and it's gone. Cool. I'm just going to remove all of this and do it another time just to make sure that it's really gone. Here. Yep. Cool. We have a safer application. This is great. Thanks, Batch. So going back to the iceberg. But yeah, first of all, what did we learn with this? So one tip, we can use Sneak Advisor to check if a package is secure before implementing it into our code base. So let me just show this cool trick. So if you go to Sneak Advisor, and you can see that we're actually serving like for ecosystem with npm, PyPy, Go, and Docker. And let's put st, the st package here. I'm going to click on this one. And the good thing is here, it's giving you package health score with 4 dimensions. So security, popularity, maintenance, and community. And here you have a better visibility on which package is free from security, from vulnerabilities. A little bit more graph around popularity, the maintainers, when was the last release, when was the last commit, some information around maintainers and the community. And this can help you making a decision of which package you like to implement. Let's have a look with the marked package. So this is great. Like this is like the perfect score. And obviously for this this demo, I've been using really vulnerable packages just for the sake of the demo. But as you can see, the latest version is free from vulnerabilities, which is cool. Cool. Then you can also use the CLI to check the vulnerabilities. I've been using the ID in our case with the Visual Studio ID integration, but you could do the same on your CLI. So let's see this. Just gonna move this. So if I do sneak test, what I'm gonna have is, so it's gonna query the vulnerabilities database, and this is gonna give you the same output that you can find here on the side. So it's exactly mirroring the same common results. So depending if you're more familiar using the CLI for this kind of data, or if you want to use the integration, yeah, like you have several options. Also, if you think there's a little bit too much info here, you can actually filter this with the, just gonna clear this. So with the sneak test, which is the severity, threshold, flag, and I'm going to put it to high. And this should come back with only the highs and critical. So yeah, in our case, you would see only these vulnerabilities here. So if you have, if you want to filter your vulnerabilities and try to tackle first the high and critical, this is a good way to go. You can also have that visibility on the Snyk dashboard if you import your project, so you can monitor your project automatically. And if there's any new vulnerabilities introduced in your application, you'll be notified, and you'll have the same kind of info as well on it. Just gonna, I've lost it. Yeah, here. So this is the one that I've imported, the Node.js goof. And if I check on the package JSON, you'll have exactly the same kind of vulnerabilities that you have within your CLI or the ID integration. And you also have the link to Snyk if you want to learn more about the vulnerability, here in that case, prototype pollution, which is cool. So if you click on this green button, fix this vulnerability, because this is usually what you want to do, you'll be redirected to open a fix PR. This is the workflow if you're using GitHub. And here you can cherry pick which vulnerability you want to fix, or you can just bulk fix everything. And this is the kind of PR that will be raised on GitHub, just to let you know, with a few merge advice, just to see if there's any breaking changes within the CI/CD pipeline that you're using, and make sure that you're running your suite of tests to make sure that everything is fine. And yeah, again, highly recommended that platform. Is great to if you want to learn a bit more about the vulnerabilities and do hands-on labs to understand more about XSS and directory path, the two that I've demoed today. But obviously, there's more vulnerabilities, and yeah, you can learn more on this platform. Let's go back to our iceberg, because we've only seen 2 layers. So the third layer is the containers layer. So an application needs to be deployed somewhere. We're using containers and static websites to deploy our projects, and we have different ways to do so. We could use Docker, Vercel, Netlify. We could use the cloud providers as well. If we're using Docker, we're adding a Dockerfile now in the equation, which has metadata about your project. And this is adding an additional layer for a modern application, because we're running our application as Docker images, and this actually adds complexity and increase your attack surface, as you can see here. So the good news is Snyk can also help you scan your Docker files. So again, if you have a Docker file in your project, this will appear under your project when you import it. But first of all, let's go back to what I can call it like a really basic Docker file. I know, but let's see what can go wrong with this ones. Well, a lot of things. Let's see them. First of all, the common software vulnerabilities. So this might be the vulnerabilities that we don't know about, like having SSH or curl that could potentially be a point of attack when you start installing packages. In this case, here you can see the image magic, and I'm going to come back to that specific package, because this one was an interesting one that allowed to perform a remote code execution. So yeah, I'll come back to that specific example in a few minutes. The other one is the dependencies. Are they vulnerable? So installing dependencies during runtime, we would recommend to do it with the only production flag to avoid pulling dev dependencies and non-deterministic package install. Also, are we looking at the security releases? Because if we're picking a large image, it might have many vulnerable libraries that we're not aware of. So are we taking the time actually to go to those security releases to learn a bit more about the context? This is an example for the node image. So going back on the Snyk dashboard, I was saying that Snyk could help you also having that visibility on the images that you're using. So they'll let you know the current image that you have with the number of severities that you have within this specific image, and also some alternative upgrades that you could potentially use within your project. And this will depend obviously on your risk appetite or your information security policy for your projects. You can also use Snyk Advisor and get some information to help you taking a decision on which Docker image will suit your project. So if I go back to Snyk Advisor and click the little drop down, select Docker, I'm going to try with Node and see what I'm having. So if I click on Node here, there's a few metadata info here, the number of stars, the number of download. But the info that we are more interested in is here. So we can select the tag. So let's say I'm using Node 14. I'm going to select this one. And this will allow us to compare Node 14 with the latest, for example. So you can compare and take a decision on which image you'd like to import and add to your project. Cool. So I've actually teased the remote code execution into the image magic package. So let me demo and give you a little bit more context around that one. So first of all, what am I talking about? What is image magic? What is image tragic? So basically, what happened? Image magic is a package commonly used by web services to process images. So if you want to resize your image within your application, you could use a package like image magic. The bad news is that one of the vulnerabilities can lead to remote code execution if you process user submitted images. And this is why they actually call it image tragic. So this is the team behind Image Magic that actually created that website to let us know more about the context and what was going on with this package and this vulnerability. Cool. So let's have a look here. So what I'm going to do is actually using an application to demonstrate this remote code execution. And I'm going to use two payloads. So as you can see at first, this is like a really simple Dockerfile. And you won't see anything really alarming here. You can tell from here, it's just like basic Dockerfile. Let's have a look at the first payload. So the first payload, what I'm going to do is use their API to trick the application, thinking that I'm pushing an image, but actually I'm going to create a file called RC1. And the second payload is still the same, using their API, but actually create a reverse shell. So I've set up the scene here before this presentation, so you don't see me as like setting up this. I've actually served a local static server to serve the netcat package here. So I'm just going to minimize this this screen because we don't need it. The most important one are these two. So this one, the second screen, is actually the connection to the Docker container. So I can just check first, who am I? I'm root. Oh, great. And do an lsla here. And as you can see, there's no RC1 file here. This is just like the normal files that you could see on this image. Cool. And here, I've just run ncat, the netcat in listening mode, just to wait for incoming connection. But this one will be used with the second payload, not the first one. So let's just focus on the first payload. So I'm going to go to this really fancy application, as you can see. But the most important is just to demonstrate the remote code execution. So let's imagine it's a really fancy application and we want to resize an image. So first of all, let's go to GitHub here and go to this one, exploits, and this. Cool. Okay, I'm going to resize this. And I have image resizing success. Okay, should we resize another image? Well, let me see what happened here, because I didn't get the image. I got like a broken image. So what happened? Uh-oh. File has been written. RC1. Okay, that's not great. Let's try the second payload. Just going to go back to the front page. Choose another file. Just going to choose the RC2 in our case. I'm going to open this one, and I'm going to resize. Look, so here it's hanging, which is usually not a great news when nothing is happening. I didn't get the second screen. So what is going on here? I'm just going to clear this. And yeah, sorry. Oh, that's not great. You can see like some files been written. Okay. So I'm going to put here, who am I, just to make sure that I'm getting roots here. And let me explain what is going on here. So we're going to have to wait about 10 to 12 seconds for the netcat utility to be downloaded from the local static file server, which is happening here on the left side. It's going to be compiled and executed to then create a reverse shell, which I'll have here, the one on the right side, that allows us to interact with the local netcat listening prompt. So basically, what I'm doing will be a connection with the Docker container. So hopefully, this is going to come back with the root. Usually takes a couple of seconds to perform this. As you can see, there's a few files that has been written in our container. Ah, here. Root. Cool. So let me check first if they have. Do they have Python here? Yes. Okay. Let me just change this to 51. I'm just going to have like a better shell. So, in bash. Make sure that I don't have a typo. Yeah, that should be fine. Cool. Okay, who am I? Root. That's not great, because if I have root access, I can do whatever I want here. So you get the idea. Now that I'm connected to the container, I can actually navigate, have a look at all of the folders, and ultimately find some sensitive info and exfiltrate it into our my server. So here you can see, like, have access to all of the folders. Yeah, just have a look, navigate, take the info, and yeah. So this was the demo for the remote code execution, which wasn't great in that for that package. And also, you might be wondering. Sorry, I'm just going to go back to this one. What is happening? Because if we go back to this Docker file, you actually don't see the image magic package here. So where could it come from? So if you have a look at this node image, actually, and this is on the README file. By the way, you can actually download this container breaking in Goof on the Sneak Labs repo that we have. And there's a little bit of explanation here. So the vanilla Node.js based image ships with a vulnerable image of image magic. So this specific version was actually implementing image magic by default. So this is where it's coming from. And you couldn't actually guess it if you haven't had a look at what this specific version had, what was the packages that it included. Cool. So we did Docker image security best practices. So where we actually recommend to use minimal-based images and also use multi-stage builds for small, secure images. So basically, when you're doing development, the development stage, you could use larger images because you want to experiment. But when you move to the production build stage, use slimmer images, which might be a little bit more secure on that side. What's the last layer? Going back to the iceberg. So we've seen the application code layer. We've seen the open source code layer where we're implementing a few packages. We've seen the container layer, which could potentially also hide malicious packages. And with the case of image magic, lead to remote code execution. But what is the last layer? What else can we have within for a modern web application or a modern application in general? IC, infrastructure as code. So that's an approach to manage data center servers, storage, networking infrastructure. It is meant to simplify large-scale configuration and management because we're provisioning our resources through code instead of manual processes, just to make sure that our application is scalable and available. So we're making our code our single source of truth, where we explicitly through codes specify all of the infrastructure specification in our config files. So we can have version control on all of our config files. We can test, we can monitor. There's a lot of really advantages using IIC. But the most common vulnerability our organization faces for IIC is cloud misconfiguration. And this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. And you have a few examples at the bottom with, for example, PlayStation. 77 million PlayStation Network accounts were hacked because of a cloud misconfiguration. For Uber, they had 57 million customer and driver info breach via Uber's GitHub Actions and AWS creds. What happened is one of their repo went from private to public, and the attacker was just scraping keys and credentials on GitHub and managed to capture one of these creds. Cool. I'm just going to demo first an example of IIC. So here you have an example of a Terraform file that is using the provider AWS here. And we're defining password policy, I've commented out a few things just to trigger some errors. I'll fix this after. But you can see there's a few modules here just to define the basic infrastructure. But the most important thing here is to just scan it to see if there's any rules that we could improve or harden our infrastructure. So I'm going to use the sneak IC test command. And this is basically going to go through the Terraform files that I've been using, and let me know if there's any rules that I can, like areas that I can improve against some rules. So here I can see that I have 3 highs, 9 medium, 7 low. Okay. There are rules around the S3 buckets, around CloudTrail, credential, security groups. The one that are interesting in that specific case is the rules around IAM password. So it should contain symbols, lowercase, uppercase. Okay, let's fix this. Here I'm just going to remove this, and this. Cool. And I'm going to rerun the sneak INC test to see if we've actually improved that the number of total issues we have here, 9 medium. Oh, let's see. So it's scanning again the our files, and we've actually improved it. So we've actually removed 4 issues here. So you might be wondering, this is cool, but where are these rules? Where are they coming from? What are all of this? So if you click on one of these rules, you will be redirected to this this platform where we're actually defining all of the rules that we have for IAC. In that case, specific case, this was the IAM password should contain uppercase, and it will give you the issue, the impact, and how to resolve it. Obviously, yes, there you have more rules for IAM, and it's not only about IAM, it's about all of the AWS services that you might be using here. Also, if you're not using AWS, we're also covering Azure, GCP, and Kubernetes. And if you're wondering where those rules are coming from, we're actually checking against the CIS benchmark, which is the Center for Internet Security, which are guidelines giving you a little bit more context and ideas how to harden your infrastructures following specific rules. So this is how it's checking against. Cool. So I think now we have a better idea of the modern application. So we've seen that at the top of the iceberg, we had the application code, which is represent 10 to 20% of our code base. Then we're moving down to the open source libraries, which could represent 80 to 90% of the vulnerabilities were found in indirect dependencies. Then we have the continuous layers with all of the Linux packages and the base images, Docker images that we might be using within our code base. And finally, the IAC level with cloud misconfiguration. So hence the importance to have guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is getting bigger. And this is a classic SDLC pipeline. So depending on your implementation and your organization, you might have different endpoints. So here today I've demoed the coding endpoint as testing with the ID integration. I've also used the CLI just to check some of the vulnerabilities. I've also been using the Sneak dashboard. So depending on your workflow and your familiarity, you could have those different endpoints. Also, you can have guardrails at the repo stage where you can test, fix, and monitor by raising pull requests. On the CI/CD pipeline, depending on if you're using GitHub Actions, DevOps pipeline, or Jenkins, Circle CI, whatever CI/CD tools that you're specifically using, you could also implement guardrails at that stage. Obviously on production also, and on the registry, just to make sure that you're fetching the correct image or packages. So that's a DevSecOps feedback loop, because we want to empower developers to build applications securely within the entire development process, and we want to avoid siloed team between security and development teams. So let's have a look at defense in depth and third practices and tech to consider. First, the open source software layer. So first of all, try to inventory your open source components. Just don't give hackers more tools to expand their exploits. Leverage security tools just to improve your security posture. Embrace automation because you want to eliminate manual activities. Make sure to also include your open source software components in use within your security policy. And you can have also that visibility using a software bill of materials to have a list of your software packages, content, and license data. On the container side, don't run as root. You probably don't need it. Also, don't use privileged containers. You also definitely don't need it. Drop capabilities when you don't need them, and allow only what's needed. So if you don't need SSH, if you don't need curl, just drop those capabilities. And also make sure to deploy from known sources and pull from known registries only. On the IAC level, secrets, just make sure that they're encrypted and have role-based access control applied. Security context, just make sure that you're not running as roots. And also you can enforce those by using open policy agents like Gatekeeper, Governor, and the tools that the Cloud Native Computing Foundations also are providing, just to enforce and harden your infrastructure. So before closing, I just want to give 5 top tips. The first one is adopt a DevSecOps approach. So this is also what we know as the shift left approach, which aims to detect security issues from day one in order to prevent those security issues to begin with and to resolve them as quickly as possible if they do indeed arise. Address open source vulnerabilities. We all love open source software and should it be like components or tools. And while it offers a great number of benefits, including cost efficiency, they also expose you to significant vulnerabilities when using OSS. Ongoing monitoring for vulnerabilities, regular updates, and patching vulnerabilities as quickly as possible are therefore critical. I'm seeing one really excited Liran in in the chat now. What is the VS Code theme? I'll share that at the end. Yeah, Vandana, just take note of that one. Yeah, I'll come back to that one. That's fine.
Sonia, that was totally amazing session. Thoroughly enjoyed it.
Vandana, I still have like a few things to just give me a couple of minutes.
Okay, yeah, all yours.
Third tips, automate simple security tasks. So we know it's virtually impossible to mitigate the endless number of vulnerabilities that exist using a manual approach. So automation is therefore critical, and all simple tasks should be automated in order to allow teams to focus more on more challenging tasks, I would say. 4, be aware of your own assets. Visibility is the first step towards gaining insight into your organization's security states, as you can secure what you haven't identified. So knowing precisely which assets make up your applications and software production infrastructure is key. And thus, we also have this discussion around the SBOM to give you that visibility. And lastly, the last tip, security training for developers, because developers were responsible for pushing code into production. So it is therefore critical that we receive training from a security team, or if you want to upskill on our own. Obviously, the training should be tailored to the specific developer's role and security needs. This is actually a good segue to useful resources that I have to share with you. So the first one is the Snyk security resources. It's basically a corner where we have different cheat sheets around different topics. So here, because it was a JavaScript session, I'm just sharing with the NPM security best practices, the React security best practices, but we also have around Docker, PHP, and other Java. Not gonna forget about that one. Yeah, so we have a lot of cheat sheets, interesting one to have a look at. Also, again, Snyk Learn. I'm really showing my love to to that platform, but I think it's a good one where you can learn more about those vulnerabilities with one pager and hands-on labs. Also, the State of Open Source Security 2022. This is a joint effort between the Linux Foundation Research and Snyk, where we actually show the current state of open source software security and some of the methods to address and improve the cybersecurity posture. So this gives you a bit more insights and metrics around the open source ecosystem. And there's the same for cloud, the State of Cloud Security Report 2022. Again, a report on the cloud risks and security challenges that organizations might face and experience. So if you want to know a little bit more about those useful insights, that's a good report to have a look at. So I'm Sonia Moise. I'm passionate about DevSecOps, open source, and cloud security. I do a few things outside of Snyk that I'm not going to bore you with today. But if you want to reach out, you can connect to at Sonia Moise on LinkedIn. I'll be happy to connect. But yeah, just wanted to thank you for this, and thanks to Patch as well for helping me today to resolve some of the vulnerabilities. Hope you've actually learned a few things along the way. Find some of the demos cool or scary. I don't know. But yeah, just wanted to say stay safe in your journey to cloud native application security. Yeah, thank you.
Thank you so much, Sonia. It was wonderful. And especially, I always love the part where we talk about open source and cheat sheets because they give us a lot of tricks and tips to do wonders in security industry. And especially for developers, it's like a gold mine where they can find anything. So totally, totally amazing. So I don't see any question but the interesting discussion with Laran. Thank you so much,
Yes.
Laran, for joining us here as a viewer.
So what I'm gonna do, I'm gonna share the response on our Discord channel, which is a good way actually for the viewers to join our Discord channel. I'll put all of the details over there. So if you want to
Super.
know how I've set up this, what do you call this? Yeah, this cool VS code setup. Yeah, you will know about it on Discord.
Amazing. So everyone do join us on DevSecCon Discord channel. There you'll find all the wonderful instructions to information about different themes, to about different cheat sheets, to everything. And most of the discussions that we've done today, we have shared the links for our open source security report, cloud security report, the vulnerability in different themes like marked, and learn.sneak.io, where we were showing how exactly you can get yourself trained, because it's a click through demo page, so you can actually check that out. And if you still want to have any discussions with us, you can reach out to us any given time. So you can reach out to Sonia Mozet, and do join us on Discord. Thank you, Sonia, for sharing the wonderful insights today. Take care,
Thank you,
everyone.
Vandana.
See you
Bye,
next
bye,
week.
everyone.
Bye.